Okay, so in our little exploding gummy bears lab that we're going to be completing today, basically what's going to happen is we have our little gummy bears, as you can see right here. Okay, and so I'm going to be giving you data about the red one. You guys are going to make a prediction about the green one in terms of colors and observations that you're going to see. We're going to have this potassium chloride, right? It's a white powder. You're going to see that. Okay, it's going to be solid, and we're going to heat it up as indicated by our little triangle up here. We're going to heat it up, and it's going to decompose into potassium chloride and oxygen gas. Okay, so this is going to be a liquid potassium chloride and then oxygen gas. And then we have basically after that, now that we've produced some oxygen, we have a tube filled with some oxygen, we're now going to drop one of those gummy bears into it. Okay, and what you see there, just looking at these first two reactants, okay, we have some sort of a carbohydrate and oxygen. That should be telling you in your mind that that is a combustion reaction, which we see the products carbon dioxide and water. None of these equations are balanced, so we do need to handle those balancing issues. So just like we said on the last one, this, as you can see, is decomposition, right? We have something that is all together. So remember when we had first learned about our types of reactions, this is something like the AB breaking into an A plus a B, right? So we have our decomposition reaction first, okay? So now that we figured that out, okay, now we have to balance this stuff out. So we have, I'm going to go ahead and draw my line down the middle. We have some potassium, we have chlorine, and we have oxygen. So looking at both sides, I see that I have one potassium on this side, one on that side. I have one chlorine on the reactant side. I have one chlorine on the product side. So everything's good so far. Okay, oxygen, I have 3 over here and 2 over on this side. So this tells us that we're going to probably be doing the thing where we're going to make it equal to 6. So what I'm going to go ahead and do is I'm going to add in a 2 in front of our first molecule, the potassium chlorate. And what that's going to do is I'm going to recount now. So now I know that I have 2 potassiums, I have 2 chlorines, and I now have 6 oxygens. So looking over at the product side, I can go ahead and fix that real quick by putting a 2 in front of this. So now I have 2 of those, 2 chlorines, and then we have to fix our oxygen. So we're going to put a 3 in front of that to make this 6. The other one that we're going to be looking at, this is the second part of it, right? So after we've melted that and we have a tube full of liquid, we're going to be dropping our gummy bear, as indicated by our glucose right here, into this tube full of oxygen. And with that heat, it's gonna combust, right? And we're going to get our little fire over here, okay? All right, so looking at the balancing here, oh, sorry, I guess I should also say, so this is our fuel plus some oxygen always makes that CO2 plus water. And that is what's telling us that this is a combustion reaction, okay? So you're gonna need that for one of your questions. Now, let's go ahead and start balancing this. So we have this line down the middle. So we saw that we have carbon, hydrogen, and oxygen. So let's go ahead and count up on either side. So on my reactant side, I have 6 carbons, okay? My hydrogens, I have 12. And my oxygens, I have 6 here and 2 here. So I have a total of 8. Over on my product side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. So nothing is balanced right now. So what I would recommend us do is let's try and see if we can mess with the fact that there are 6 carbons on our reactant side. Let's go ahead and fix it over here. So I'm just going to go ahead and put in a 6 in front of our carbon dioxide. I'm going to recount that. So now I know that I have 6 carbons, I have 12 oxygens in my carbon dioxide, and 1 over here. So now I'm up to 13 oxygens, okay? All right, we also see that we have this 12 to 2. So what I'm going to do here is I'm going to go ahead and put a 6 in front of my hydrogen, and I'm going to recount that. So now I have 12 hydrogens, and I have 6 oxygens here, 12 here. So now I'm up to 18. Okay. And so now we're going to come back over to this side. And what I see here is I have my 6 oxygens and 2, right? So that's how we got our 8. So what can we put in front of this to make it equal that 18? Hopefully you're saying 6. So if we do that, then now I have 12 coming from right here and 6 over here, and we are now balanced. So it is a 1 to 6 to 6 to 6 mole ratio.